We've had some wonderful new memberships recently as well from members of Maine's startup community. We have a lot of connections to the kind of 128 loop sort of business financing entities, startup financing. So through our affiliation with Clean Tech Open. So if we can be a connector for you or your new idea, that's our job. Let us know. Thank you for rejoining. I mentioned John and Wood PLC and others. Many of you recently rejoined. Memberships go for a year, and it's just whatever you sign up. If you sign up now in September, then it'll be next September. We do make it free for public officials, and that's one of the ways that we keep people involved. And Joe Staples and Tom Twist both know all our events are free for students, which is nice. We really appreciate your support. We've been doing more promoting our events on Instagram, and it seems to be working, which is cool. We are focused on diversity, equity, and inclusion, and basically what we think we can do is find people of diverse backgrounds, interesting perspectives, jobs within our network. And just this morning, our E2 Tech board member, David Ertz, was telling us about a new hire at E2 Tech member BRI Environmental. Helped that individual get through the credentialing process and so forth. So we're pretty proud of that, and we're happy to help. We do lots of work with MTI. We're gratified to have a chance to work with MTI and their programs there. If you have a new idea for a product line, something that's edgy. I met recently with solar shingle developer, and it had just this really interesting insight. And something like that is really the type of thing that MTI really wants to get behind. It doesn't have to be a startup. It can be a new concept for an existing business. As long as it creates jobs and innovation in Maine, MTI is there for you. And we are kind of your concierge service within the environmental and energy sector for working with MTI and helping that organization grow, be more effective. Speaking of growth, these four companies are all contributing to E2 Tech at the $2,500 a year level, which is a huge help. Our total annual budget as a nonprofit is only about $180,000, so it makes a really big difference to us. So please patronize these companies. And I always like to linger on this slide here with many these sustaining stewards. This is at the $1,000 level, and the same thing. It makes a huge difference to our organization to have this level of support. We are largely a membership funded organization. We are nonpartisan. We don't lobby or advocate. And that's kept us going for 20 plus years. And that's sort of part of our magic. I note that Tim Soley is here from East Brown Cow, in the upper right. And I note that Key Capture Energy, which is an innovative energy storage company, is kind of jammed on here in the bottom, but we appreciate them just as much. And Key Capture Energy is our most recent sustaining partner, and Generac just renewed. So thanks. If you need connections at these companies or want to work with them, let me know, because they certainly work with us and support us. And these companies all sponsor all of our events year round. And I want to highlight TRC. Our board chair, Tom Eschner, works at TRC, and VHB is a wonderful supporter as well, all year round. And Maine Biz, would you like a free print subscription to Maine Biz? This really works. A lot of people take us up on this. I myself have one of these. And something that's interesting about Maine Biz and the print subscription, it comes out very promptly. And a lot of times things are in that before you'll see them online. So it's a great way to stay updated. There's a new issue every week. They will mail it to your house for free as an E2 Tech member. And we got some cool events coming up. There's one of these literally a week from today. Have you, at this very same time, have you wondered, we've been doing more in Zoom land with getting perspectives from other states. We have a presenter at an upcoming forum that we're talking to, for example, who comes from UC Irvine, University of California. We probably wouldn't be able to fly this individual in, But anyway, we're sort of taking that to heart with our planning of events these days. So E2 Tech member Sachin Garadia is was previously employed in helping develop New Jersey's energy master plan. He was telling me about that, and I said, hey, how about you tell us about that? I know people will be interested in it. And he particularly worked on the EV incentive side of it, but that should be a good one, free for E2 Tech members. And 2 weeks from Thursday, members have been telling us that you want networking events that don't involve particularly me talking at you, but basically anybody. So just a chance to get together. Are you a solar EPC that's looking for new clients, or are you an environmental expert that wants to build your network, or perhaps an attorney in the field? These events are for you. We've been getting 60 or 70 people, and they've really been going well. We are looking for sponsors for that, and sponsors do get nice highlight. And then hydrogen, we are doing a hydrogen forum. Hydrogen is a really interesting solution paired with renewable energy and looking at storage, and also for converting heavy industry, decarbonizing heavy industry. E2 Tech Program Committee will publish something very soon. I almost had a date today. We're that close to getting it forum published. I think it will be October 20. I'll tip that, but I think that's going to be a big one. So here we are. This is a Zoom meeting. You are meant to be interactive. I might even push you to be interactive. I am the moderator asking the questions today. Charlie is an excellent engaging speaker, but I will need your good questions, because you do not want to hear my questions. You want to hear yours. Be thinking about that. You'll get the recording and a PDF version of the slides. So after Charlie presents, you may ask your questions just by popping up on the screen, or you can put them in the chat and I will pose them. If anything goes sideways, contact Riley or I. And with that, it's my chance to introduce Charlie Levesque. Charlie has done all kinds of work in this field of forestry in this emerging sector of carbon. So Charlie, tell us more about what you're working on and what you're seeing ahead.
Okay, great. I'm going to put my slides up here and ask you to confirm that you can see them.
There they come. Nicely done.
You have full screen there?
There they go. Yep.
Okay. And I assume that that you can hear me as well. So, so thank you so much for having me on here. I wear a number of different hats. I'm president of a consulting company, Innovative Natural Resource Solutions. We have offices in Portland, Maine, and also in New Hampshire. I'm based in New Hampshire, spent a lot of time all over the Northeast, and my partner is Eric Kingsley. Some of you certainly know Eric. But I've got a different hat on for today because I act as the contract executive director for a little nonprofit called the Northeast State Foresters Association. And we've got a USDA Forest Service grant-funded project called Securing Northeast Forest Carbon Program. So that's under which we're operating for this talk today. I'm going to focus this on forest carbon, and more particularly forest carbon as it relates to mitigation of climate change. So just a little bit of background on the whole program. It's really targeted at forestry professionals and those who work with forest landowners, and also forest landowners in the 7-state region of New York and New England. And it's a 3-year project. What we're trying to do is get the latest and best information out on forest carbon and forest carbon markets for that audience, and really anybody else who's interested in order for those folks to make informed decisions about forest management and whether or not they want to sell carbon in the forest carbon markets. So it's really focused, as so much of Maine's forest lands are, as on working forest land. It's not intended to be a set-aside program, but we'll be talking a little bit about that. Some of the techniques do go there. So each of the states has a lead person in our program, and in Maine, with the Maine Forest Service, is Don Mancius. You can contact Don, or you can contact me. My contact information will be on the last slide, and I welcome phone calls and emails as well on anything having to do with this. Not a fancy website, but a website absolutely chock full of everything forest carbon is kind of where our stuff is. And I encourage you to go there and study it. It'll take you days to get through it. We really have tried to make it a clearinghouse where everything is there for you. We also have an e-newsletter, and you can go onto that homepage and sign up for it if you're interested in this topic. So in May of this year, we had 4 webinars that were rather lengthy combined. They were over 7 hours worth, and these were the topics. And for today, I'm excerpting from those webinars. So if you want much more detail, what I'm going to cover today, go to the website and see those webinar recordings and the PowerPoints that are there. So I'm going to talk first a little bit about science of forest carbon, and then a quick overview of the science of forest carbon management on forest lands, and then lastly, talk about forest carbon markets, which many of you are probably interested because there's real money being traded for selling forest carbon offsets. So I put this slide up here because I want you to know that most of what you'll see has actually been pulled together by Dr. Ali Kosiba, who is with now the University of Vermont. She just switched jobs. She's the state extension forester with the University of Vermont, and she is certainly a premier climate forester and forest carbon expert in the region. And so I've hijacked a bunch of her slides, and just know that that really they came mostly from her with a little tweak here and there from me. But there's some great stuff here, and slides worthy of studying. So I encourage you to go back and look at the PowerPoints that are there. So let's start a little bit on some of the basics and talk about the global carbon cycle. So remember, we've got mega pools of carbon on the planet, not just in the atmosphere, but we've got in the ocean, in deep geology, also in soils, and the biogenic side, which is what we're going to focus on here, the plant side, particularly trees. And carbon is moving from one of these megapools to others all the time, from various natural processes. So just keep this in mind. The circles are intended to represent kind of the amount of carbon that are in these megapools, so you get a sense of the scale of some of this stuff. And I always like to start out by this. I'm sure this crowd knows what this is all about, but I encourage you to talk about this greenhouse effect with people that you know, because I do it all the time, and you'd be surprised at how people think they know what's going on, but actually don't when it comes to the science. So I encourage you to share this concept with folks and ask them if they get it, and if they don't, really kind of help them out a little bit. And of course, the concept is, we need to have our atmosphere traps some heat, otherwise we wouldn't have life on this planet. But what's happened since the Industrial Revolution is that we've been sending so much additional greenhouse gases, particularly carbon dioxide, into the atmosphere, that our atmosphere is now trapping more heat than it used to, and consequently things are changing with the climate and with the temperatures on the planet. So I guess you probably know that, but don't assume everybody knows this. So from a carbon perspective and forests, this is really kind of where it all begins when we're talking about climate change. 2 really important graphs here, and I'll kind of talk about these very quickly, but just remember these 2 if you could. The one on the left is from 1750 to basically the present. The blue is the CO2 emissions over time. You can see the Industrial Revolution changes in emissions that occurred, from the late 1800s, and then the concentrations of CO2 in the atmosphere are the brown line on the graph. And so you can see they're in lockstep as we emitted more carbon and greenhouse gases from fossil fuel combustion primarily, that the amount in the atmosphere in parts per million obviously increased. I think you already know that. The more interesting graph for me, especially for those who are naysayers, is the graph on the right. And there's 2 graphs there. The top one is looking at carbon dioxide over the last 800,000 years. And obviously we're talking about ice core analysis here that gets us way back there. But you'll notice something between that one and the second one, the temperature graph, is that they're virtually mirrors of each other. And so what that tells us is that temperature on the planet is directly linked with greenhouse gases in the atmosphere. And so while some of the greenhouse gas increases over time over the last 800,000 years were natural and not human caused, this last blip in recent years is in fact, and it correlates directly. So very important graphs, but that one in particular is the one I like to use if I'm talking to somebody who's a real skeptic around climate change in general. So what do trees do? Trees do some really important things when it comes to carbon and greenhouse gases. You may remember from your high school biology that trees are essentially sugar makers. The photosynthesis effect is taking in carbon dioxide from the atmosphere, and that's what's so important in this discussion, plus water, plus sunlight. And from there, it makes food, its own food, sugars, and it turns that into wood and leaves and other biomass, and also use water and carbon and oxygen. It also, trees also respire as any living thing, so it actually gives off carbon dioxide as well, much more so during the wintertime than during the growing season. But just know that these are machines that take in carbon dioxide, which is a critical thing as it relates to climate change. About half the weight of dry wood is in fact carbon. So it's a critical factor. There are other things on some of these slides that I'm not talking about. I encourage you to go back and study some of those things. We're trying to get through this in 20 to 25 minutes. Some key terms to remember here when it comes to forest carbon. Carbon storage is the actual amount of carbon that's stored in the trees, whatever scale you choose, per acre, per tree, per state, that's carbon storage. That's what's already been sequestered in the past. So sequestration is the actual act or rate of take up of carbon dioxide by trees. Different from storage, totally related because sequestration yields storage. And then, of course, carbon emissions come from all kinds of sources where those sources, both when fossil fuels are burned and when biomass is burned as well, release carbon dioxide to the atmosphere. And then, kind of the difference between those two is the carbon flux, whether something is a sink, meaning a negative intake over a time period, or a source or a positive source into the atmosphere over time. Carbon dioxide equivalent, CO2e, is kind of the term that we use to be able to compare it to other greenhouse gases. But just know that the metric that we're using is metric tons of carbon is what we're talking about. So in the region as a whole, again, this program's looking at these 7 states. Currently, the standing timber, the standing trees in the region are retaining about 54 years of the region's current annual greenhouse gas emissions, a huge amount. And yes, this map shows gradations. The dark green on the map shows where the highest concentration of standing carbon is in the forest of the region. You'll notice that Maine is mostly lighter colors, a little bit of spillover from the White Mountain National Forest and northwestern Maine, but Maine on average it has younger forest and forests that don't have as much timber stocking on them, and consequently less carbon. You'll notice the second graph here really looks at average total forest carbon per acre, and you'll notice that the other states in the region are pretty similar. Maine has a bit less per acre, and it's simply because on average, the trees in Maine are actually smaller than in the other states of the region. Furthering some of this, and you'll notice some of these graphs go downward, and downward in the sequestration world is good because that means take up, net take up. The flux is a negative, which is a good thing, taking up carbon over time. And so these just show it by state, the sequestration levels. And then the last one is a very interesting one, the blue one, really looking at the total forest carbon sequestration as a proportion of the state level greenhouse gases, right, per year. So look how much of Maine's forests, what Maine's forests do relative to the emissions in Maine, the highest in the region, right? So Maine's forests are taking up about 70% of the greenhouse gases that are emitted in Maine in a year. So I'm going to talk about some things related to forests in detail, but just know that whether a forest is a sink or a source is dependent on a bunch of factors, climate factors like moisture, temperature, and length of growing season, site factors. Not all soils are the same, and elevation and aspect are all important, whether it's on the north side and gets a shorter growing season, or on the south side of a hill and a longer growing season. And of course, tree factors themselves, different species and genetics of trees, affect whether or not they're taking in more carbon over time and storing more carbon. But not all forests in the country are sinks. Ours in the Northeast are, in fact, sinks. Every state is, and combined they are, obviously, but I don't have to tell you about all that's been going on in the West and really last 20 years especially. And there are many states in the West that are heavily forested that are no longer carbon sinks. They're actually net carbon sources because of the wildfires that occur. We also have natural disturbance, which can affect whether something is a sink or a source as well. So moving on, some important other important terms. Think about forest carbon pools. It's not just forest, it's a bunch of different pools within the forest, right? From above ground biomass, live trees that we think about, to below ground live biomass. There's a fair amount of biomass that's alive in the root systems of trees. We've got litter, soil, deadwood. Look at the pie charts on the left. Very important from a storage perspective. Actually, more than half of the carbon that's in the forests of the region is in the soil. Obviously, the above ground biomass and all of that woody material above, whether it's alive or dead, also has quite a bit, but soils have a tremendous amount. But that's the storage. On the sequestration side, the above ground live trees are where the biomass actually increases because of sequestration of carbon dioxide and the growth of the timber and the wood. You'll notice that the soils themselves have a very small annual sequestration rate. So they've got a lot of carbon. They don't add much to it as time goes on. Two really important graphs. Hopefully I can get these concepts across. Think of these as a typical forest in the region. The x-axis is showing time up to 125 years, and the y-axis is showing carbon storage per acre, right? And so what happens in a forest over time as it grows from a young forest to an older forest, and believe me, 125 years is not a real old forest in the region. But you notice that, of course, it's increasing in carbon stored in the trees over time, but you'll notice that that rate of change starts to level out. And if we continue this out another 125 years, that level of increase would pretty much flatten out. So we get to a point where the forest is no longer actually net sequestering carbon, because when you get to old forests, they start dying naturally. And at that point in time, they may even out or even start to reduce as the forest actually dies off. A different graph, but related 100%, and here's where you got to think negative is good, is this graph, the other one showing storage over time, this one showing actual sequestration rates over time. The big take home from this one is very simple. And the green one is the above ground biomass, the live trees. This is showing that fairly young forests from ages around 20 to 50, in that range, are the forests on our landscape that sequester the most carbon per acre. That's extremely important. Older forests sequester less per acre or per landscape. And that's the ball game when it comes to what we're thinking about in terms of forests sequestering carbon and helping to mitigate climate change over time from today and into the future. This doesn't mean we want to cut down old forests and put young forests in their place. There's a lot of misinformation out there that suggests that older forests sequester the most carbon per area, and that's simply not true. Bigger trees do sequester more than smaller trees, but younger forests sequester the most over the area, and that's the important metric from today and into the future. So don't forget, as we harvest forests for all kinds of useful products, some of those products, solid wood products, stay as carbon, stored carbon for a long, long time. They stay in that form and can stay well over 100 years. And so even though we harvest some forest, some of it goes into long-term storage. And so we're actually not losing it back to the atmosphere. If we burn wood in the way of firewood, chips, or pellets, we certainly do release that to the atmosphere, but is coming from the biogenic cycle. It has been in the atmosphere, the trees took it up, and we combust it, and so it's in that biogenic cycle, as opposed to taking fossil fuels from the geologic side of the earth and bringing out new carbon to be released into the atmosphere. So jumping to the second section here, and I've just got a bullet list here. I have slides for each of these, and if you go to those slides on the website, you'll see these, but I'm just going to go through a bulleted list to give you a sense of the kinds of things that we can do to make changes as we manage forest to benefit carbon and climate change mitigation. The first and key one is to keep forest as forest, avoid forest loss to other non-forest use, because we know that forests do a great deal to sequester carbon and help us to mitigate greenhouse gas emissions from other sources. But if the forests go away and we go into a built environment or even an agricultural environment, we lose the sequestration capability. Yes, establishing reserves where we don't harvest trees and we let them grow, especially if there are those young or mid-age trees that I talked about in the earlier graph, whether it's a permanent kind of designation or temporary, obviously that can be a positive as well. Not so much in an older forest. There are other reasons for establishing reserve in an older forest, but sequestration rates are not one of them. Storage is. We can extend the rotation of a forest. That means what is the interval between the times that we harvest? When we do that, obviously we're keeping more trees on the ground, more storage, and also more sequestration as time goes on before we harvest. And for existing forests, we have a lot of forests in the region that are what we call overstocked. In other words, there are too many trees on the site for maximum growth and maximum sequestration. And by careful thinning, we can increase growth rates in order to increase overall sequestration on those forests. Now, I mentioned before that younger forests are those forests that are sequestering the most per area, and we can certainly increase areas of younger forests. There are other reasons to do that as well, because there's a lack of young forest habitat in the region as a whole, so it benefits wildlife and other things, but we don't want to do that by clearing really old forests necessarily. Sometimes it happens, and hopefully a lot of those old forests, the timber goes into solid wood products, but we want to be careful as we're regenerating stands into younger forests, but those are the forests that sequester the most. We want to retain some big trees across the landscape. Even if we're converting to a younger forest, we want to keep some of those big old trees on the landscape because they have a lot of carbon storage and they are beneficial over time in that regard. We can increase stocking in these forest areas, as I mentioned, where there is understocked areas or no stocking of trees, because that also is underutilization of an area for forest. We want to increase tree species diversity. There's a whole range of reasons why we want to do that, but when we do that in a forest in the region, we have multiple species of evergreen trees and deciduous trees. They take up various niches and can better command the site to get the most sequestration and storage out of it when it comes to carbon. We also, when we get machines in the woods, they can do a lot of damage on the existing trees. And we want to make sure to limit that so that the remaining trees after a harvest are growing at their maximum. We also want to protect soil during harvesting. Winter harvesting is especially good in that regard. Winter is a great time to harvest trees. We harvest all seasons of the year, and we can be careful about it during the non-winter months, but winter is a great time. And when we do it during the warmer months, we need to make careful not to damage the soils. And then, of course, getting as much into durable wood products and boards and timbers and other solid wood products is the best. And these days, we're actually looking at the forest products harvesting supply chain, from the machines that harvest the wood in the woods to the trucks that bring them to the mills, and even in the mills to reduce overall emissions in that supply chain. I'm not going to talk about this graph because it's very complicated when you first look at it, but only to say this came out of the Maine Carbon Task Force final report. Very interesting stuff. So of all those things I just talked about, some of them cost more to do than others, right? And so where do you put your efforts? Well, this graph kind of tells us where you get the biggest bang for the buck. So you get on the y-axis the cost of activities, and on the x-axis essentially the benefit of forest sequestration. Notice avoid forest loss is way on the right and down at the bottom. So in some respects, it's not the least cost, but a lesser cost and high benefit task that we can do to make sure forests are doing all they can for sequestration. I encourage you to look at this at another time. So I'm going to finish off here by talking about forest carbon offset markets. So the concept is simple. I'm sure most of you know what this is about. And it is simply those who are emitting greenhouse gases. Hopefully they're trying to reduce their emissions at the source, whether it's a power plant or a factory or transportation, but they can't necessarily do as much as they want that way. And so to offset those emissions, they can purchase carbon offsets from various sources. Forest carbon offsets are actually the biggest traded subset of carbon offsets overall. And so you purchase those to offset your emissions is the general concept. So in the forest carbon offset world, there are three types of offsets that can be sold. Afforestation, that's really taking areas that don't have trees and planting trees, or encouraging natural regeneration like we do in the Northeast to grow, to get forest on areas that are not forested. Avoided conversion to non-forest, but the one that's primarily used in the marketplace is this third one called improved forest management, where you're altering the management on the forest land over time, and that's yielding more sequestration and more carbon storage over time, and you get paid for that in an offset. So carbon market terminology, pretty simple. There are these marketplaces, they're actually virtual, and I'll talk a little bit about how that works after, but where forest carbon offsets are actually bought and sold. There are registries, which are, think of them as kind of the gatekeepers or the rule makers on how these systems work. How do you know when you're buying a metric ton of carbon that's actually happened? And that's what the registries do in setting up methodologies for maintaining that and to assure that those that are listed on the registries are real. Carbon developers are private or nonprofit companies that help landowners get these projects together. You generally can't do this without one. It's a very complicated process for someone to build a carbon project that then gets sold in that smaller circle on the bottom. And so these are all the parts of the carbon market. So there are two types of carbon markets that exist. There is the compliance market, and right now it really technically is only as a result of laws in the state of California through their Air Resources Board. We have this thing called RGGI. I'm sure you're all familiar with the Regional Greenhouse Gas Initiative. It's been around in the eastern states for quite a while, and it has rules that would allow for carbon offset markets, but they don't work. So nobody has ever sold a metric ton of carbon from forest offsets through RGGI. So on the compliance side, it's just California. And what is growing rapidly is this voluntary carbon market. And think of this, it's not regulated. Government is not involved at all yet. I wonder whether that will change in sometime in the near future, but it isn't right now. Think of Microsoft and Amazon and airlines who want to offset their emissions. Oftentimes they're going into the voluntary carbon market to do that. And again, the registries do control what goes on there, but government's not involved. So how much is it worth? Well, there's a big difference generally between the compliance market and the voluntary market at this point. In 2021, the price in the compliance market was about $30 a metric ton of carbon dioxide equivalent. And in 2021, it was more like $6 in the voluntary market. But I know personally from some particular projects that it varies widely in the voluntary market. I know somebody who sold carbon in the voluntary market for over $30 a metric ton in 2021. So it's all over the place. This neat thing called ecosystem marketplace is keeping track of all the prices. And that's where these prices come from. It's really the only place you can get that. If you Google it, you'll be able to find it. So what about these carbon registries, right? These gatekeepers or rule makers. There aren't hundreds or 20 of them. These are them. And so there's very few registries out there from which to choose. And really, we're talking about the ARB that the California program is involved with, and then Climate Action Reserve, American Carbon Registry, and Vera. Those are really the ones that we're talking about, because the Reggie one doesn't really practically exist, does not really work. And when it comes to those carbon developers, there are also not hundreds of these companies and nonprofit entities. There are really, about 10 that really do most of the work. They're kind of in two categories: those that do it for big projects, and Maine has had it. You've got projects that are 100,000 acres up in Maine where people have sold carbon. What I didn't mention between the compliance market and the voluntary market is generally the compliance market is a 100-year commitment, whereas the voluntary market is something more like 40 years. I'm going to drill down into those four that were on the right of the other slide. And these are the ones that are working with smaller landowners. Prior to really about 2 years ago, anybody that had less than 5,000 acres really didn't have a marketplace to sell their carbon if you wanted to sell forest carbon offsets. But Forest Carbon Works, Core Carbon, which is just getting going, the Family Forest Carbon Program, and NCX are those that are there. I got an X over NCX for a reason. They had their methodology, because it's a very different program than the other three. They had essentially 1 year timber harvest referrals as their program. In other words, they paid you to not harvest timber for a year. It started in the Southeast, where rotations for forests are much shorter than they are in the Northeast. They had that methodology before one of those registries, Vera, and Vera essentially said they were not going to approve it a couple of months ago. And so they're kind of in limbo. I'm not saying they're going away, but at this point, it's not clear whether they continue. What we've done on the website is we've taken all of these programs from the various developers, and we've kind of compared them, so you can kind of compare apples to apples. So I encourage you to go on the website to look at that to get a better sense for it. A few more slides here. So there's some key requirements, and I can do a slide for each of these that the registries use, that to make sure that a metric ton of carbon from forest carbon offsets is real, additional, verifiable, permanent, enforceable. Additional means, if this project hadn't happened, is there a difference between that and what happens when the project actually goes forward? So is it truly additional and benefiting the climate of the planet? Verifiable, it's got to be something that you can actually measure on the ground, and then it's permanent. It has some duration. I have those 40-year time commitment I mentioned for the voluntary markets, or 100 years for the compliance market. So very important that these offsets have some kind of standard, and that's what it's about. Very important concept is one of leakage, and leakage is this. Some of these developers require that all of your lands go into the project, not just a portion of them, because if only a portion goes in, then possibly, even though you've decided to defer a harvest or do a thinning where you might have done a heavier harvest on your property, you then go on your other property and cut a lot harder. So that's activity shifting leakage. And then in the world as a whole, that's market leakage, right? That says if you change your practices here, maybe somewhere else trees get harvested or get harvested more because you've reduced the harvest in your property. So this is a very important concept, and I've spent a lot of time recently looking into this, and I'm concerned about the leakage issue. So when a landowner is thinking about doing this, they need to ask carbon developers a whole bunch of questions. And I've got a list here. We've got those on the website. We're going to have a much more detailed list of the kinds of questions you should ask if you're a landowner. It's really important to know what you're getting into, because in the end, you're going to sign a contract. It might be for 20 years for the Family Forest Carbon Program, or 40 years for the voluntary market, or 100 years for the compliance market. But it's a serious thing. It's as serious as contemplating selling or donating a conservation easement on your property. So you better know what you're getting into, and you better have counsel that knows what they're doing. And the concept of forest carbon offsets is not without controversy. There's all kinds of stuff that's already occurred in the media, and I'm sure you've seen some of these things. There are skeptics out there, and some for good reason. And that's going to continue. Just know that there are many that are scrutinizing it, and there's a lot that are concerned about it. As I mentioned, you can sign up for our e-newsletter. One went out yesterday, and just go to that homepage on the website and you can click on the button to sign up for it. And here's my contact information, and that is my presentation. Hopefully we'll have a good 20 minutes here for Q&A.
Truly excellent, Charlie. Really, really good. A lot of good information packed in. And so what I often do, and I'm going to ask you to do now, is turn on your camera for my signature smiling screenshot. And I have a reason that I do this, which is it gets people to kind of engage, and a little smile wakes you up. So if you wouldn't mind doing that on the count of 3, I'm just going to grab a little screenshot. It's good to see everybody. This is nice. Okay, 1, 2, 3. All right, I got you. So there's been some great questions that have come in the chat. And is there anybody, perhaps Jody, could I pick on you to start off with a question?
Sure. Let me just drill back so that I can see what I wrote. Yeah, I thank you so much, Charlie, for a packed presentation in a very short number of minutes. I just was wondering if you could go back to the slide that you showed fairly early on that showed the relative stocking rates of New England states, and where it essentially showed Maine as a lighter color due to the state's younger trees relative to other New England states. And I was wondering how that illustration really squared with the idea that were there to be a regional carbon market established that was really, effective for forest carbon credits, it seems like neighboring states, particularly Massachusetts, views Maine as a likely source of carbon credits that other states, let's say Massachusetts, I'm just picking on them, would be interested in purchasing. And this slide makes it look like there wouldn't be credits available to purchase. And so I just want to understand that a little better.
Yeah, so this is where the two concepts come in. Sequestration, right, which is the rate, the amount of take up over a time period, and then storage, right? So what this graph is showing on the bottom here is that on average, Maine's forests store less per acre than the other states. However, Maine's forests are younger on average than the other states. And so remember, I put that strong concept forth that the forests that sequester the most carbon are in fact younger forests, 20 to 50 years old. Maine's forests are younger, so the rate of sequestration that occurs on Maine's average acre is generally more than those on this map where you see the dark green, because those forests are older and the rate of sequestration is less than in Maine. So when it comes to actual markets pay for two things. They actually pay for what has occurred in the past. In other words, the storage on the land today, but they also into the future through modeling and then borne out by measurement over time, pay for sequestration starting when the deal closes into the future, right? So just because Maine's forests are not stocked as heavily on average as other states doesn't mean that they aren't going to be in demand for carbon projects. In fact, they are. And on a project from a landowner's perspective, an acre that has less storage today, but a younger forest is going to sequester most during that 40 to 100 year period that you sign a contract. So, it's two sides of the coin in selling offsets. I hope that helps a little. So it doesn't necessarily mean that other states are going to be more in demand than forest land in Maine. And just understand that many acres have already been sold in carbon offset projects to date across the region, and some big ones in Maine as in the other states already.
Excellent question, Jody. And Jody, by the way, I think many people know, did a wonderful job facilitating the series, which you can find on YouTube, I believe, under the Maine Climate Council on forest carbon. So thank you, Jody. I want to go to Woody Bartley for what I think will be a relatively straightforward question, although I'm not sure about that. And then after that to Nancy, who's got a question, then maybe Bernard after that. Woody.
Hi there. Now I saw in one of the charts, it was referring to mostly hardwood forest. Is there much of a difference between hardwood and softwood forests for sequestration?
Right. So good question. So if you know anything about wood, hardwood, say a cubic foot or cubic yard or metric, if you will, of hardwood wood is going to weigh more than that same volume of an evergreen tree, right? Like a pine or a spruce or a fir, right? So that means that hardwood trees are more dense and they also have more carbon because they're more dense. Because as I mentioned, by weight, the dry weight, about half of that is carbon. So on average, hardwood trees are going to be more dense and have more carbon in them.
Still, that's key.
Similar size tree compared to a softwood and a hardwood.
But there's the concept of both what's stored standing and then also the rate of uptake, which I imagine is an interesting permutation of that. But Nancy, I know you had a couple of good questions. Would you jump in?
Yeah. Let's see, am I on?
Yep, we got you.
I'm interested in, since the Forest Service has been pretty understaffed in foresters for decades, but I think in the last 5 years added a number of foresters. Are they sharing this information with the small woodlot owners in southern Maine who own a significant amount of forest land? And now it looks like you can have 30 to 40 acres and still be eligible for Blue Source or Family Forest programs. So I think that's the obvious source of information for those folks to give them these incentives while also teaching them better forestry practices.
Yes, so good question. And this whole program was set up to, in fact, do that, Nancy. So both the foresters that work for the Maine Forest Service, but also the cadre of private foresters that work in Maine, they were the first targets for education. So everything that's on the website was targeted at them. Remember, I said we got over 7 hours worth of detailed information from which I drew this PowerPoint, and the foresters in the region have all had the opportunity to go through that, and hundreds have, both in the public side and in the private side, because the whole purpose is to get information out about forest carbon and forest carbon markets, in fact, to those landowners, not only in southern Maine, but all through Maine. So that's the whole purpose of this program.
Good. That's great information. And let's keep the questions going. Bernard from Finsalate and various other ventures, and I know is part of New England Ocean Cluster over at the Hoos, where we're hoping to do an E2 Tech event before too long. Bernard, I know you got a couple of good questions.
So before that, 10, 15 years ago, I was involved in forest management and forest ownership, and we decided not to take that path as a philosophical approach, which was, on one hand, it's a speculative market. So basically, if you have like one reduction of carbon at one point, then this offset will be like traded. And so the market is inflated by the speculation coming into the market. That's one side. But the other questions I had is, we've seen over the last few years, and especially last year and the previous year, articles in the press, FT, BBC, everywhere, about actually carbon offset forests that went into flame. So what happens to the offset?
Yeah, so excellent question, right? So not only fires, but there are other natural kinds of disasters that can occur in the Northeast. You know, we're more likely to have either hurricanes or more likely microbursts, small groups of tornadoes. It happens all the time. So if you've got a forest where you've sold the carbon on it for the next 40 or 100 years, what happens if your forest burns or goes down? So remember I mentioned these registries, as part of their systems, they require a certain amount of forest carbon that's part of the deal to be set aside in a buffer pool for the registry as a whole, if you can think of it as many projects, not just one. And so if that kind of thing occurs on one of the properties that had carbon in that registry, then they will take from that pool to make up for it. So in fact, they do take into account the fact that there are natural disasters that can occur, and so are able to put some extra in the bank, if you will, that a landowner does not get paid for, that is simply a buffer to take into account those situations, which will happen.
Okay.
Excellent
Thank you.
questions. Thank you, Bernard, and interested in your background in that you've done so many incredible things. I see a chat coming in from State Representative Lori Osher. Thanks, Lori. I wanted to go to a question from Mark Power from Train, and Mark is an energy services team leader at Train. I hope you're already working with Tim Soley, Mark, but if you're not, you should be. But go ahead and ask your question.
Yeah, hi, Charlie. Thanks. Great presentation. Really enjoyed it. As I think about the level of interest in this and working with clients, and also on the personal side, working with the local land trust that I'm involved in, that it's got 5,000 acres under their care. I'd like to be able to pitch them on this and say, this is a great program, you should get involved. But until I'd like to understand a little bit in terms of what we're looking at from a dollar value per acre to enroll in one of these programs. And I know they're all over the board, but if you could just give us a sense of what kind of value landowners would be looking at to, because it looks like there's a bit of pain and probably some cost associated with getting yourself set up to go into a program. So what's the revenue associated with that, or just kind of a range, if you could?
Sure. A wide range, again, taking into account whether the forest has a lot of storage on it, it's well stocked today, whether it's going to grow fast in that period in the future. It might be, anywhere from $5 to $30 or $40 per acre. So a fairly wide range, but certainly not much more than that range. So that's kind of what you're talking about. And I would suggest that more of them might be on the lower end of that. So it really depends how the deal is structured. So every one of these carbon deals have a contract for a period and have the terms. They're not all identical, right? So that's why it's so important to have somebody who knows what they're talking about involved when the negotiations occur, because it's a long-term commitment. Also, prices for carbon offsets over time change, right? So as I mentioned, there's kind of two plugs of money, right? There might be a plug of money right up front when you sign a contract that might represent in those projects that are related directly to being paid for carbon. One of the ones for the small landowner doesn't pay for carbon. It actually pays for practices, but we won't go into the details. But so you might be selling carbon, actually selling it today at current rates. But in 20 years, you might also be selling carbon that sequesters 20 years from now, and it will be at whatever carbon offsets are worth then. And obviously, we can't know that, right? So these contracts, certainly talk about the fact that you're going to be paid whatever the marketplace is paying, or whatever it could be sold for in some time in the future, right? So lots of variables, and you got to weigh it fairly carefully. And remember, if you've got a decent amount of land, doesn't mean you can't cut timber also. All of the large landowners that have done it, think of those that have 5,000 or even 100,000 acres, they continue to harvest timber on their property, right? Think of it that every year, a certain amount of carbon accrues to those forests, and they might get paid for a little bit of it, but they can still cut a little bit of that also, right? As long as that buffer is there. So you can have your cake and eat it too, especially if you have more land compared to somebody who might have 50 acres. It might be not as simple as that for a smaller ownership. So you get a range of prices there, but it's all over the place, and you really need to study it carefully before you make a decision.
This is great. A lot of good questions. I want to go to Melanie and then Tim, and then I think, unfortunately, a closing statement from Charlie. Melanie.
Thanks so much, Charles. I can see if everyone or everything works perfectly here and all actors are acting selflessly, you can see how forest carbon programs could work really well to fight climate change. But one of the arguments you've no doubt heard is that offset programs are just an excuse for polluters to keep polluting, and that they won't make every effort to reduce emissions. So I'm just wondering how you respond to those criticisms.
Yeah, that I put up that slide of criticisms of all the stuff on purpose, right? And that's certainly what we've heard in a lot of places. And let's face it, if somebody chooses to buy offsets, forest carbon offsets are not the only ones, but as I mentioned, it's the by far the vast majority of the offsets that are being bought and sold. in fact, they're not reducing their outright emissions, right? Because they've chosen, at least for part of their program, to buy an offset that somebody else did some good with, and then take it as their own by paying into the marketplace, right? So I think there is definite truth to that. If they're doing it voluntarily, right, as opposed to required to be done either through RGGI or through the California Air Resources Board, emitters in California actually have to reduce emissions and make up the difference with offsets. But if they're doing it voluntarily, and the choice is to do nothing in terms of reducing their emissions, or buy forest carbon offsets or offsets, then maybe there's a plus if they do spend the money. But if they're going to do it in lieu of reducing emissions, you're absolutely right. I think it's an excellent point.
Yeah, what an interesting discussion. Thanks for diving into that, Tim.
Thank you, Marty. So Charlie, I have an interesting question. It seems like the optimal paradigm is something along the lines of cogenerative purpose, meaning the species of flora that is most carbon sequestrative, would that be the proper term?
No, but it's a new one now.
Okay. And which would also have other value. I mean, forest land, forests have value for building, yes. But there may be other species of flora that may have better purpose. And what made me think about that is your data that the older forests have not as much benefit because as they
in the future time. Today and in the future, right? They had their benefit in the past when they sequestered, but yeah.
Right, but so it's all about growing. It's about maximum growing periods. It's a life cycle of flora that have maximum life cycle during a certain period of time. So that's the metric that you're trying to solve for. And then the cogenerative perspective that there may be another use for that product. Is there anyone looking at that in terms of understanding what should we be growing and how it should be grown and where and what time frame of its life cycle?
Yeah, there are a lot of people looking at all that stuff. You can imagine that this is a very hot topic. Forests are where the plants we call trees sequester the most carbon across the planet, right? Compared to grasses and other annual kinds of vegetation. So there's a tremendous amount of interest in all of academia and looking at all of those kinds of things. There's a lot of people looking at the kinds of things that you mentioned. Are we better off doing other things with our forest, or is this a good use? I will simply point out the fact that we can have our cake and eat it too, right? We can do many things with our forest, including contribute to mitigating climate change, right? It's not an either or, right? So forests have all kinds of values, from recreation values and timber values and carbon values, et cetera. And there are ways to do all of these things on essentially the same acreage of land so that we get the maximum benefit out of our forest. We already do that now. This term that was coined in the 1960s by the U.S. Forest Service called multiple use simply means that our forests can do many different things. And carbon is just an added ecosystem service that we can do in addition to those other ones. And I encourage everybody to think about this, not just about selling carbon in the markets, even though that's an exciting kind of sexy thing that can be done. But all those practices I mentioned that you wouldn't necessarily get paid for, but you could do as a landowner. If you care about climate mitigation and want to do right by that with your forest, you don't necessarily have to get paid for it. You can do those management practices that I mentioned. And that is part of what we're doing also for those landowners that don't want to commit to 40 or 100 years, but want to do something. You can do something and not get paid for it, yet still get all those benefits from your forest. So hopefully that helps. It's a good question.
Yeah, that's remarkable. We got to go to a closing, but Charlie, I want to say two things. One is we have a networking event 2 weeks from Thursday at 3 of Strong in Portland. Maybe we can get you and Eric to come to that so we can talk about this over a cocktail. We have another event just like this on New Jersey's energy plan next week. But there's a question in the chat from Dr. Joseph Stables at the University of Southern Maine. Maybe use this as a closing, Charlie. Is there an opportunity for offsets to include how timber will be used post-harvest? Maybe somebody manages a harvest for a particular market or something like that.
Yeah, excellent question. And the simple thing is the marketplace already kind of takes care of that, because a tree cut that is what we call a saw log, a high value stem, goes into solid wood products, and to the landowner and to everybody in the supply chain, that tree is worth many times more using that tree for pulp to make paper or for energy, although we do like to use wood for that purpose. So nobody's going to take a high quality log that can be made into those
Yeah.
long life products that are also long-term storage of carbon, and put it into a low value product. So the marketplace already has a good handle on that. We could provide more incentives to in fact grow more, a higher percentage of that high quality. So I think you got something there, but it's a good concept, but the marketplace is actually set up to do exactly that now. So we all want to grow those high value products that go into those solid wood uses that are long lived.
Thank you. Thank you, everybody. This was a hit, Charlie. Applause from all of us. Nicely done. We will send you the recording and the slides and also the chat. Really great presentation. Please come see us at our event a week from today, and stay involved with E2 Tech. Keep your ideas coming to us, because that's how we develop these. And I'm guessing we might have ourselves a full forum here for this one, because there was a ton of interest, that is for sure. So we will wrap it there. Enjoy your afternoon, and I look forward to seeing you in person in Thursday, September 29th at 3 Strong in Portland. Thank you again, Charlie. Really well
Thank
done.
you.
Cheers. Take care.